All right, good morning. Hopefully this is going to work. I'm having problems getting it to um, be viewed in the normal formatting, so hopefully this will work. If it doesn't, then I'll upload this um, to the Google Classroom, and you can just use that and listen to this at the same time. So we're going to talk about the different types of rocks today. Yesterday we talked a little bit about the different types of minerals, so this time we're going to talk about the different types of rocks that can be made with those minerals. Just a refresher, a mineral is a naturally occurring inorganic substance found on the earth. They've got a set structure, they've got a set chemical composition. Mineraloids are basically the same thing as this, except they do not have a set structure, whereas the minerals do. And then rocks are structures that are composed of minerals and other sometimes pieces of dirt or animal remains or plant remains or something like that. And these rocks their characteristics are going to determine on how they were made. So there's 3 different types of rocks that you can find in Earth. Quick refresher though on how to classify your minerals. Remember, we can classify them according to color, luster, cleavage, streak, hardness, and their specific gravity or their density. And then you've got those other special properties. Those are the physical properties. And then you've got some special properties like fluorescence, magnetism, radiation, radioactivity, taste, optical properties, things like that. So that's how we determine those particular parts of the rocks. So again, just a refresher. So there are 3 different types of rocks. We have igneous, metamorphic, sedimentary, and, well, those are the 3, sorry. So igneous, metamorphic, and sedimentary rocks. Those are the different types of rocks we've got, and like I said, they're classified based on how they're formed. So we're going to start first with igneous rocks. Igneous rocks are going to be formed when you have either lava above ground cooling or magma below the ground cooling. That's the only difference between lava and magma. Lava is found above ground, magma is found below ground. It's basically molten rock or melted rock. The only difference, like I said, is just where they're located. So they can cool fast or slowly, and this is partly how we define or characterize them, classify them, igneous rocks. If they are cooled very, very fast, usually that means they were formed above ground, or we say they're an extrusive igneous rock because they're formed above ground or outside extrusive. Because of that, because they cool fast, they don't have the time to form crystals. So you can't see the individual minerals, you can't see the individual crystals, you can't because they cool so fast. However, if they're below ground where there's intense amounts of heat below the ground, then they are usually cooled a little bit slowly. And because they're cooled slowly, those rocks are able to capture some of those minerals or crystals, the individual minerals or crystals. And so these particular ones tend to look different colors. And so you can usually tell how fast it's cooled based on the size of the crystal. If they have very large crystals, they were formed or they were cooled very, very slowly. If they have smaller crystals, they were probably formed quicker. Obsidian is an example of an extrusive igneous rock, and granite is an example of an intrusive igneous rock. And I've got pictures here. I'll come back to that other slide. So this is a picture of obsidian. Hopefully you can see that. It's very glassy in its appearance, but it's got no crystals. You can't see any parts or pieces, any individual minerals. That's because it was cooled very, very fast. This is an example of granite. And so you can see the little individual shiny crystals there. So that would be considered an intrusive igneous rock. Since the crystals aren't particularly large, we can assume that it was formed not super slow. Maybe not super fast, obviously, because it wasn't above ground, but not super slow either. So, going back, just kidding, too far. Going back now, there's 3 different classifications besides the extrusive and intrusive rocks that we can classify your igneous rocks as. The first being coarse-grained, so you can see the individual crystals. So those are going to be those intrusive igneous rocks. But then we've also got fine-grained igneous rocks, which are, they've got the individual crystals, but they're just not visible to the unaided eye. So you'd need like a microscope or something to be able to see those. So the rocks tend to look dull or one color, but they do technically have crystals, so they're still intrusive rocks, but they're going to be more quickly formed than the coarse-grained. However, they're going to be slower than the extrusive rocks. Glassy rocks are going to be no crystals are formed at all. So those are definitely going to be those extrusive rocks. So if you look at these pictures right here, the obsidian would be glassy, and then the granite would be a coarse-grained rock because you can see the individual crystals. And then since the obsidian looks glassy, it's shiny, it's not going to be fine-grained because it's not dull. So those are igneous rocks, volcanic rocks. All right, metamorphic rocks are the next group, and they're going to form when heat and pressure within the earth cause the rock to change its texture and composition, or change the minerals. Metamorphic or metamorphosis actually means to change. So if you're at all familiar with the Franz Kafka story Metamorphosis, where he turns into this gigantic beetle, that's why it's called metamorphosis, because he changed. So that's why they're aptly called metamorphic rocks. So there are 2 different ways that we can classify metamorphic rocks. We can classify them as being foliated or non-foliated. If they're foliated, the minerals look like there's some layers in there, or they might look like they have some bands. Non-foliated metamorphic rocks are not going to have bands or layers. So marble and slate are examples of metamorphic rocks. So marble is an example of non-foliated. So, okay. Not too much on metamorphic rocks there. Your sedimentary rocks, this is the third group. This is going to be formed when rocks undergo these 2 processes of weathering and erosion to form rocks, and then they will eventually undergo lithification. So weathering, erosion, and lithification. Lithification's on the next slide, by the way. So these rocks undergo weathering and erosion to create these sediments or pieces of rock. Weathering is when rocks are going to break down by chemical or physical means. So it could be by wind or sunlight, people walking over a sidewalk where it starts to crumble or something. That could be examples of physical weathering. Chemical weathering would be breaking down due to maybe acid rain, turning it into something else. Erosion then is the action of actually removing the pieces of rock by wind and water. So you're actually removing those pieces of rock. Limestone and sandstone are examples of sedimentary rock. The Grand Canyon here in the United States is a lot of sedimentary rock is there. If you ever make it down to the Lake of the Ozarks here in Missouri, kind of in the center of our state, there's tons of sedimentary rock there. You can always tell sedimentary rock just because they always have bands. They really look layered. Our state rock is limestone here in Missouri. Again, I don't know if Italy has a rock. So, okay. So the way that sedimentary rocks are actually formed is your sediment, your pieces of rock, after they've been weathered or eroded, they're going to be compacted, cemented, and hardened through that process of lithification. So that was the other word that I used. So sedimentary rocks are formed through erosion, weathering, and then the process of lithification. The lithification is the actual forming of the rock. The erosion and the weathering is breaking apart the pieces to make the sediments that lithification will need to actually make the rock. So compaction is kind of what it sounds like. You're compacting things, pressing things together. So those pieces of sediment are pressed together. Cementation is going to occur when water precipitates into those spaces between the sediments. It's going to act like a glue, so kind of like cement. And then the hardening part is where when the water evaporates, that solid rock is left behind. Those pieces of sediments are now physically attached to one another. This is the only rock type that would contain fossils because the amount of heat that is required for metamorphic rocks to be created is too high. And the amount of pressure, the fossils wouldn't withstand that immense amount of heat and pressure. Same with igneous rocks. The fossils would not survive the process of the melting down in the magma. So if it can melt the rocks, it's going to melt the fossils. So sediments, the layers of sediment get layered or deposited, what we call deposition, the depositing of the sediments on top. And so that's how your fossils can be left behind. You know, the pieces of sediment just get laid on top of it. And then, yes, there can be some compaction, but that amount of pressure isn't enough to destroy the fossil. And so sedimentary rock does a very good job of preserving fossils. So, and we'll use fossils to help determine Earth's history. So what we're going to look at now is one law in geology. It's called the law of superposition. It helps geologists determine the relative age of the rocks, which I'll talk about here in just a second. But what it states is, assuming there's no change in the position of the rock layers, the oldest rocks will be on the bottom and the youngest rocks will be on the top. The same can be applied for fossils. Assuming that there's been no change in position of the rock layers, the oldest fossils will be on the bottom and the youngest fossils will be on the top. So, like I said, it helps determine the age of the fossils. It's only going to give you the relative age. So, for example, relative age is just what order they were in. If you were to see a family that has 3 kids out, you know, at a restaurant, chances are very good you could tell which of the 3 children is the oldest, which one's the middle, and which one's the youngest, unless you're running into a set of multiples like twins or something. But usually you can tell what order they were born. Now, you may not be able to tell the exact age, like this one's 13 and that one's 8 and that one's 4, but you could definitely put them in order. That's relative age, is just putting them in order according to when they were formed. So this law of superposition is also, I usually tell people that it's kind of like the laundry basket law, if you use a laundry basket. The oldest clothes that you've worn, or the ones that were worn the longest ago, are going to be at the bottom. The ones that you've most recently worn are going to be at the top, because you're going to put them in like layers, just like rocks are deposited in layers. Sedimentary rock are deposited in layers. Assuming you haven't gone through and rifled through your laundry basket looking for a pair of socks or something, or a pair of jeans. If you go through and rifle through, you're mixing up the order of the laundry, and so then this law would no longer apply because now there's been a change in the position of your clothes. So with this particular law, we're talking about things like earthquakes. Assuming that there haven't been any reason for the rocks to have changed their position, you should be able to tell which ones are older and which ones are younger. The other type of age that you can get is called absolute age, and we would determine absolute age through a process of, oh, there it is, radioactive dating. So radioactive dating is when we use radioactive elements found in some of the rocks. They can give us the exact age of the rock. When I say exact, we're talking like within a couple hundreds, maybe thousands of years, but in the grand scheme of things, when you're talking about a couple hundred or 1,000 years versus billions of years, you know, a couple hundred years, give or take, isn't that big of a deal. So what they actually do is they know that specific radioactive elements go through a process called radioactive decay, meaning they're radioactive, so they give off that radiation, but over time they're going to break down. Okay? When they break down into non-radioactive pieces. They might break apart into lead or something. So they might break down from uranium into lead or something, where that byproduct is no longer as harmful as the radioactive part. And they know how long it takes for those radioactive elements to break down. And we're talking thousands and thousands of years to break down radioactive elements. So based on how much of the radioactive element is there versus how much of the byproduct is there, they can determine how old that rock is, because they know how long it takes. You know, if they have so much of the radioactive material, they can look and see, well, how much of the byproduct do we have? And based on how much of that byproduct there is, they can determine, well, how long is it taken for this radioactive material to turn into this byproduct. And that will give them the exact age of the rock. So that kind of gives you kind of an understanding of the different types of rocks. So if you do have any questions, let me know. Tomorrow we'll kind of review over minerals and rocks. And like I said, I think I'm going to probably have you take a quiz on Tuesday. So over the minerals and the rocks. Like I said, this is going to be a much shorter unit, so we'll probably have some more material next week, and then the following week we will, so the week right before spring break, we'll probably look at having your test, is where I'm going, because there's just not a lot. I mean, we could obviously learn more, but I don't think you need that, so according to your little list. So if I'm mistaken, just let me know, but as always, if you have any questions, just let me know, and have a good day.